Let's now look at local analysis when we have a nonlinear fixed point. So let's take as the example f of x is equal to minus ax cubed. So again, if we plot the function of x dot equals f of x. So this is a cubic equation that comes into the origin with zero slope, something that looks like this, and we have a stable fixed point at the origin. So the equation that we have to solve to understand the local analysis is x dot is equal to minus ax cubed. And because this function does not have any linear term, what we did in the last slide no longer works. However, in this particular case, if it's just purely a cubic equation, we can integrate this equation exactly. And so let me just write down, and I'll leave that as an exercise for the student to actually figure out the integration, but x of t is equal to x at time 0 divided by the square root of 1 plus a x of 0 squared t. In the long time limit, notice that when t is very large, we can forget about the 1, and then the x naught squared in the square root cancels the x naught in the numerator, and this asymptotically goes like 1 over the square root of at. An important observation that comes from this is that instead of having exponential approach to the fixed point, we have slow approach to the fixed point. In fact, it's sufficiently slow that if we compute how long does it take to get to the fixed point, the time to reach the fixed point is actually infinite. So that's an important difference between linear and nonlinear flows near a fixed point. Now, the other type of example that we could think about was, instead of nonlinear fixed points, we can think about nonlinear marginal points. For example, of f of x is equal to bx squared. And while quantitatively there are differences, the qualitative behavior in this case is similar. If we start with a value x which is negative, then we're going to be drawn towards a fixed point. Let's focus only on that particular case. So if x of 0 is negative, then we are drawn towards a fixed point, and asymptotically, x of t goes like 1 over bt for x of 0 less than 0. So once again, there is slow approach to the fixed point, and again, the time to reach the fixed point is infinite.